Welcome to month 1 of the Claude Certified Architect track. This is the first of 6 monthly sessions, and it covers the core foundations that every production-grade Claude architect needs to master. By the time we finish, you'll have built a working multi-agent system, written a production Claude deconfiguration, and designed a structured data extraction pipeline. The 5 focus areas for this session map directly to the 5 exam domains: agentic architecture, MCP tool design, Claude code configuration, prompt engineering for structured output, and context management. We'll move through all 5 today, combining theory with hands-on implementation. The session is organized into 4 hours, each with a distinct focus. The first hour covers agentic architecture and MCP tool design. Together, these represent 45% of the certified architect exam weight. The second hour moves into Claude code configuration and prompt engineering for structured output, covering another 40%. Hour 3 is pure hands-on implementation. You'll clone a starter repo, build a support agent, and write your Claude. Mainly. Hour 4 closes with context management strategies and participant presentations. The exam weight distribution matters for how you prioritize your study time. Agentic architecture at 27% is the single largest domain. It underpins everything else. But all 5 domains are assessed, so depth across the board is what distinguishes exceptional candidates from proficient ones. The agentic loop is the execution model that drives every Claude agent. Understanding it deeply is the foundation for everything else in this track. Every iteration of the loop consists of 3 phases. In the observe phase, Claude receives new information into its context window. This might be a user message, the result of a tool call, or an environmental state update. In the think phase, Claude reasons about what to do next, select a tool, generate a response, or request clarification. In the act phase, Claude executes a tool call, emits structured output, or delivers a final answer to the user. The loop continues until the stop reason is end turn, which signals that Claude has completed its reasoning and has no more tool calls to make. The Claude Agent SDK provides 3 core primitives for building agents. The agent wraps your system prompt, tool configuration, and model selection. The tool is a callable function with a JSON schema input definition. We'll build several of these today. The agent executor manages the loop itself. It tracks conversation history, fires lifecycle hooks, and handles the alternating assistant and tool result messages that the loop requires. Lifecycle hooks are where you add observability and control to your agent. The onTool start hook fires before each tool call, ideal for logging, rate limiting, and pre-execution validation. The onTool end hook fires after the tool returns, capture latency, detect errors, and update your audit trail. The onAgent finish hook fires when the agent produces its final output. This is where you write to Azure Monitor for compliance. One critical design principle: each loop iteration consumes tokens. A 200K context window fills faster than you expect, especially when tool responses return large JSON payloads. Design your agents to terminate early when confidence is high, rather than looping indefinitely looking for certainty that may never arrive. Once you have the basic agentic loop, the next design question is, when should you use multiple agents and how should they be organized? There are 4 canonical orchestration patterns, each with distinct trade-offs. Sequential orchestration is the simplest pattern. Task A completes before task B starts. Use it for pipelines where each step depends on the previous output. For example, validate an incoming document, enrich it with external data, then persist it to the database. Sequential is straightforward to implement and easy to debug, but it offers no parallelism, making it the slowest option. Parallel fan-out is the pattern you reach for when performance matters. Multiple independent sub-agents run simultaneously, and their results are synthesized by an orchestrator. For a customer support agent, this means checking fraud status, retrieving the customer profile, and verifying account balance all at the same time, rather than one after another. This is how you achieve 5-second P95 latency targets. The trade-off is that you need a synthesis step and you must handle partial failures gracefully. One sub-agent failing shouldn't crash the entire resolution flow. Hierarchical orchestration is the pattern for complex domains. An orchestrator delegates 2 subspecialists, an account management agent, a payments agent, a compliance agent. Each specialist has a focused system prompt and a narrow set of tools. This reduces hallucination risk by narrowing each agent's context, but the per-tier context overhead adds up quickly in deep hierarchies. Dynamic routing is the most flexible pattern and the hardest to test. A triage agent classifies the incoming request at runtime and routes it to the appropriate specialist. You don't need to know the task type at design time. The agent discovers it. The challenge is that routing logic can be opaque, and tracing failures across dynamic dispatch paths requires robust observability. CeylonPay is a Sri Lankan fintech processing over LKR 2 billion in monthly transactions. It's the running example throughout this track because it has real-world complexity, compliance requirements, high-value transaction thresholds, and a diverse set of support scenarios. The customer support agent architecture places the orchestrator at the top of the stack. It holds the system prompt that defines the agent's identity. You are CeylonPay's AI support agent, and it has access to 4 MCP tools: Get Customer, Lookup Order, Process Refund, and Escalate to Human. These tools are not embedded in the agent code. They're served via the MCP protocol from Azure Container Apps instances, sitting behind Azure API Management. APM acts as the gateway. It enforces authentication policies, applies rate limits, and writes every tool invocation to an audit log. This separation is intentional. It means the same tools can be used by different agents, updated without redeploying the agent code, and permissions scoped independently. The business targets that shape this architecture are specific: first contact resolution of 80% or better, meaning the agent resolves the issue without human handoff for at least 4 out of 5 cases. Escalation is automatic and mandatory for any transaction above LKR 500,000 or any fraud flagged account. The Escalate to Human tool is called with no discretion applied, and every tool call is logged to Azure Monitor with the tool name, input summary, latency, and outcome for compliance auditing. MCP, the Model Context Protocol, is the protocol for exposing tools and resources to Claude in a decoupled, reusable way. Understanding tool schema design is critical because a poorly designed schema is one of the most common causes of agent misbehavior. The Process Refund tool on this slide illustrates every important design decision. The name is in snake case and uses an action verb. This is convention, not decoration. The description is the most important field in the entire schema. It tells Claude when to call this tool and contains a critical constraint: idempotent. Calling with the same idempotency key multiple times has no additional effect. That sentence prevents double charges. The input schema is a full JSON schema object, not a description, not prose, but the literal schema. The reason field uses an enum constraint, limiting Claude to 4 valid string values. This prevents hallucinated reasons like customer unhappy from entering your payment system. The required array includes all 4 parameters. Write operations should have no optional fields for their critical parameters. If idempotency key were optional, Claude might omit it under certain conditions, breaking your duplicate prevention logic. Idempotency deserves a moment of emphasis. Network retries happen in production. If your process refund tool is called twice with the same idempotency key, a UEDV4 generated by the caller, the second call should be a no-op that returns the result of the first call. Without this, every network retry is a potential double charge. The distinction between error types matters for how Claude responds to failures. User error, for example, an account ID that doesn't match the expected format, means Claude can self-correct by fixing the input and retrying. A system error, the downstream payment processor is unavailable, means Claude should stop retrying and escalate. Claude is the configuration file that tells Claude Code everything it needs to know about a code base. It's the contract between the developer and the AI, defining context, constraints, available tools, and behavioral rule tools. The CeylonPay example on this slide is a complete production configuration. The project context section establishes the technical environment. Nest.js microservices Monaco, LKR 2 billion in monthly transactions, PCI DSS level 2 compliance. That compliance line is essential. It tells Claude to never log card numbers or NetC numbers in plain text, even in debug output. The rules section encodes your team standards as hard constraints. TypeScript strict mode means no any types. Parameterized SQL queries only means no string interpolation in database calls. The PCI DSS comment requirement means every block of code that handles payment card data must have an explanatory comment starting with PCI DSS. This creates a searchable audit trail in the code base. The skills section declares 3 agent skill directories. Claude Code reads these skill MIMD files when triggered. The ASEPA section registers the Azure APM endpoint with bearer authentication. The /commands section creates 3 shorthand commands that invoke the corresponding skills. There's an important scope distinction to understand. The file at Claude. It's a global configuration that applies to all projects on your machine. The file at Claude in a project root is project specific and always wins in scope conflicts. When you're testing whether your Claude and the rules are being applied correctly, check which configuration file Claude is actually reading. Use Claude Code debug to see the full config chain. Plan mode and direct execution represent a fundamental trade-off. Plan mode causes Claude to produce a step-by-step plan before executing any changes. Use this for destructive or complex multi-file operations where you want a human review checkpoint. Direct execution means Claude acts immediately, appropriate for well-scoped, reversible tasks like formatting a file or generating a test. An agent skill is a self-contained package of instructions and resources that extends what Claude Code can do. It lives in a directory with a skill, the file at the root, optionally accompanied by a scripts directory for automation and a references directory for domain knowledge, checklists, and schemas. The CLonPay configuration declares 3 skills. The pre-review skill triggers on review par or a pull request CI event. It analyzes the stage diff for logic errors, security issues, and code style violations, and outputs structured JSON with severity level, line number, and a concrete recommendation. The test generator skill triggers on generate tests or when a new file is pushed. It generates just unit tests covering the happy path, edge cases, and error branches, respecting Nest.js module boundaries and existing mock patterns in the codebase. The security audit skill triggers on security audit or on merge to the main branch. It checks for PCI DSS violations, SQL injection vulnerabilities, insecure credential handling, and missing authentication guards. It fails the CI pipeline when it finds hitch severity findings. The description field in your skill, ND is a selector. It determines whether Claude auto-triggers the skill based on what it's being asked to do, or whether it waits for an explicit command. Write it precisely. A vague description leads to skills being invoked at the wrong time or not at all. Reliable structured output is what separates a proof of concept extraction pipeline from a production system. There are 4 techniques that combined reliably achieve over 98% schema valid responses. JSON schema grounding is the most impactful single change you can make. Include the exact JSON schema object in your system prompt, not a description of the schema, but the literal object. When you describe a schema in prose, Claude makes reasonable interpretations that often don't match your exact field names or types. When you provide the literal schema, Claude conforms to it precisely. Few short examples address the edge cases that a schema alone cannot capture. For Nix extraction, provide 2 examples, one with an old format NSE, 9 digits plus V or X, and one with a new format NIC, 12 digits. Claude generalizes from these examples to handle variations it hasn't seen before. Chain of thought extraction is the technique for fields where the source document is ambiguous. Ask Claude to reason through the ambiguous field before committing to a value. For example, explain which digits of the NSE you use to determine gender, then output the JSON. This externalizes the reasoning and allows Claude to catch its own errors before they're baked into the final output. The validation loop is a production requirement. Ask the output JSON. Validate it against the schema using a library like JSON schema. If validation fails, extract the specific error message and include it in a retry prompt to Claude. Cap retries at 3. If all three attempts fail, route the input to a manual review queue rather than discarding it silently. When your schema validity rate drops from 98 to 85% after a new document format is introduced, the diagnosis is almost always that the few short examples don't cover the new format. Add representative examples and the rate recovers. Writing an effective code meant for the SalonPay Nest.js monorepo means working through 4 components in sequence. Start with the project context section. Be specific, not this is a fintech app, but Nest.js microservices monorepo processing LKR 2 billion in monthly transactions, PCI DSS level 2, never log card numbers, CVVs, or NIC numbers in plain text. Specificity here shapes every Claude code interaction in the project. The rules section encodes your team's non-negotiable standards. TypeScript strict mode with no any types, parameterized SQL queries without exception, PCI DSS comment annotations above any payment card handling code, and a health endpoint requirement at health for every new service. The skills and MCP server declarations require precise paths and valid authentication configuration. / commands must reference the actual skill directory paths. A command that points to a non-existent skill path will fail silently. A critical security note. The Azure API bearer token and any API keys must reference Azure Key Vault secret names, not literal values. The pattern is to store the secret in Key Vault and reference it by name in your Claude. Never put credentials in configuration files that end up in version control. After writing your configuration, review it against the deliverable checklist. Project context present, rules covering all 4 requirements, 3 skill paths declared, MCP server with bearer auth, 3 / commands with valid paths, and syntactically valid YAML throughout. And our 3 begins with environment setup, then moves directly into the challenge. The starter repository has scaffolding in place. The agent loop is already implemented, and you're filling in the tool schemas, system prompt, and Claude. In the configuration, start by cloning the starter repo and installing dependencies. Pip install Anthropic JSON schema and npm install GUI model context protocol create server. Copy nv example to nv and add your Anthropic API key. The API key must be for an account with access to Claude 3, 5, Sonnet 2241.022. Verify MCP server connectivity by running Python Swift server PyTest. This should return the list of available tools. If it fails, the Azure API endpoint in your NV is misconfigured. Once setup is confirmed, the challenge covers 3 deliverables in 40 minutes. Build a customer support agent with 3 MCP tools. Get customer profile, lookup transaction, and process refund. Write the Claude. Made for the sample SalonPay repository. Write a JSON schema grounded extraction prompt for Sri Lankan XD documents. The pre-flight checklist on this slide covers the 5 prerequisites. Python 3, 11 or later, with Anthropic installed, a valid Anthropic API key. The MCP server scaffold installed globally via npm, VS Code with the Claude extension, and Azure CLI authenticated to the SalonPay tenant. By the end of hour 3, your agent should be able to take a support query. I was charged twice for my groceries at Kales yesterday. My account is CP213456778 and resolve it end to end. Look up the customer, find the duplicate transaction, and process the refund with an idempotency key. Managing the context window is one of the most underestimated skills in production agent architecture. 200K token window sounds enormous until you're running a multi-turn support conversation with large tool responses. The token budget for Claude 3 Sonnet breaks down like this. The system prompt typically costs about 2,000 tokens, tool schemas add roughly 1,000 more, and conversation history grows with every turn. You should reserve a minimum of 4,000 tokens for output to avoid getting cut off mid-response. The target is to consume no more than 60% of the available window per agent turn, leaving headroom for multi-turn conversations. When conversation history approaches 150,000 tokens, it's time to prune. The multi-turn pruning strategy is keep the system prompt verbatim, keep the last n turns verbatim, and compress everything older than that into a rolling summary block. The summary should capture the key facts established so far: customer identity, issue description, actions already taken, without the full back and forth dialogue. Multi-agent handoffs require a minimal context principle. When the orchestrator delegates to a payment specialist, it should not pass the full conversation history. It should pass a scoped payload, customer account ID, transaction ID, a specific question to resolve, and relevant constraints. Full history passed to every subagent wastes tokens and leaks context that the specialist doesn't need and shouldn't have. Human in the loop escalation for sell on pay is a hard business rule, not a suggestion. Any refund above LKR 500,000 or any fraud flagged account must trigger escalate to human. This check is implemented as a pre-execution guard in the orchestrator's lifecycle hook before the tool call is made. The self-evaluation loop is the final reliability layer. After the agent generates its response, prompt Claude to review it. Does this response resolve the customer's issue? Does it comply with Sell-on-Pay's escalation policy? Flag any concerns. This catches errors in the response before it reaches the customer. The Azure DevOps pipeline integration brings Claude Code's code review capabilities into your automated build process. The Claude Code review stage runs only on pull request builds, not on every commit, keeping the cost and latency manageable. The review job has 3 steps. First, it computes the git diff of changed TypeScript files and passes it to preview I, which calls Claude with the diff and the prior review skills instructions. The output is a structured JSON file containing review findings with severity levels, line numbers, and recommendations. Second, post by comments. Pi takes those findings and posts them as comments directly on the pull request via the Azure DevOps API. Third, check review gate. Pi reads the findings and fails the build if any HS severity items exist. The Anthropic API key is sourced from Azure Key Vault through a variable group named Sell-on-Pay secrets. The pipeline references it as Anthropic API key. This is a correct pattern. The key is never hard-coded in YAML, never stored in source control, and can be rotated in Key Vault without touching the pipeline definition. The 3 CI/CD automation stages cover different trigger points. The PR review stage runs on every pull request. The test generation stage triggers on feature branch pushes when new files are detected. The security audit stage runs on merge to the main branch. Each stage uses a different agent skill with instructions appropriate to its context. The gate criteria define what constitutes a blocking failure. Each severity findings, security vulnerabilities, obvious logic bugs, PCI DSS violations fail the build. And medium severity findings are posted as warning comments, but don't block the merge. Low severity findings are informational and appear in the review thread without any gate enforcement. The structured extraction pipeline handles 3 document types that Sell-on-Pay processes for customer onboarding and compliance: Sri Lankan national ID cards, bank statements, and KYC application forms. For NET extraction, the required fields are NIC number, birth date, gender, issue date, and is expired. The critical edge case is the NSE format difference. Old format NICs are 9 digits, followed by V or X, while new format NICs are 12 digits. The NICS number itself encodes the birth date and gender. For new format NICs, digits 3 through 5 represent the day of the year, with values above 500 indicating female. Your few short examples must cover both formats. For bank statement extraction, the fields include account number, period start, period end, closing balance, and a transactions array. Multi-currency statements and negative balances from overdraft accounts are the most common failure modes. The closing balance field must be typed as a signed number, not constrained to positive values. For KYC application extraction, the fields are applicant name, business registration, directors, and annual revenue. Missing directors is a valid case for sole proprietorships, so the directors array must allow null rather than being required. The 4-step pipeline processes every document the same way. The schema-grounded system prompt with few short examples goes to Claude first. The response is parsed as JSON and validated against the schema using JSON schema. Validate. If validation fails, The exact error message is included in a retry prompt, not a generic please try again, but the specific field path and constraint that failed. Maximum 3 retries before routing to manual review. For cost optimization, use Claude Haiku 4.5 as the default model for extraction. It's significantly cheaper at high volume. Add a confidence threshold. If the extracted output contains more than 2 null fields where values were expected, rerun with Claude Sonnet for better edge case handling. This gives you Haiku economics on the majority of documents while maintaining Sonnet quality where it matters. Understanding what goes wrong in production agent architectures is as important as knowing the patterns that work. These 5 pitfalls account for the majority of failures seen in real Claude deployments. Over-engineering the agent loop is the most common mistake, especially for engineers coming from microservices backgrounds. The instinct is to decompose everything into specialized agents. But each agent boundary adds context overhead, increases failure surface area, and makes tracing harder. Start with the simplest thing that works, a single well-prompted Claude code. Add agents only when you have a clear context boundary or a genuine specialization requirement that a broader system prompt can't handle. Vague tool descriptions cause Claude to select wrong tools or fail to code tools at all. Difference between get customer and retrieve a SalonPay customer profile by account ID format CPXXXXXX returns name, KYC tier, account status, and contact details is the difference between reliable tool selection and guesswork. Treat your tool descriptions as production code. They're part of Claude's decision-making logic. Claude. Scope confusion leads to unexpected behavior that's hard to diagnose. When you're wondering why Claude isn't following a rule you've specified, the first thing to check is whether it's reading the global config or the project config. The project level Claude. Modi always wins over Claude. Indeed. And you can verify which file is active using Claude code to debug. Context bleed in multi-agent handoffs wastes tokens and leaks irrelevant information to specialist agents. Passing 20 turns of conversation history to a payment specialist costs 20 to 40k tokens. Passing a minimal payload, account ID, transaction ID, specific question costs 500 to 1000 tokens. At production scale, this is a significant cost difference, and the specialist doesn't benefit from the extra context. Pro schema descriptions in system prompts cause Claude to hallucinate field names and invent additional fields it believes would be helpful. Always provide the literal JSON schema object. Never describe the schema you want. Show it. The month 1 assessment consists of 4 deliverables, each worth 25 points, for a total of 100 points. The passing score is 75. The first deliverable is the agentic architecture design. This is a written document that includes a mermaid or ASCII diagram showing all 3 SalonPay subsystems, support agent, developer productivity tooling, and extraction pipeline. It must document all 5 required MCP tools with complete JSON schema objects, error codes, and idempotency strategy. It includes a sub-agent delegation model with justification for the context scope boundaries, a token budget, and pruning strategy for the context management section, and 3 architecture decision records covering why MCP over inline tools, orchestrator versus single agent design, and plan mode versus direct execution for CI/CD. The second deliverable is the working agent SDK prototype. This is running code. The agent must handle 3 support scenarios end-to-end: refund request, account balance query, and fraud dispute. The process refund idempotency must be demonstrable with a test that calls the tool twice with the same key and shows the second call is a no-op. Escalation logic must trigger correctly for amounts above LKR 500,000. Lifecycle hooks must log true start and end with timestamps. The README must include setup steps and a sample interaction transcript. The third deliverable is the Claude mini configuration and CI/CD design. The Claude mini must be syntactically valid and cover all 5 required sections. 3 agent skills must be fully defined with meaningful trigger descriptions. The Azure DevOps pipeline YAML must be complete and runnable, not pseudocode, with keyword secret binding and PR comment output. The plan mode decision matrix must cover all 5 scenarios with justified reasoning. The fourth deliverable is the prompt engineering and evaluation report. 3 complete JSON schemas for NIC, bank statement, and KYC documents. A results table populated with real test data, at least 10 cases per document type. Edge case analysis documenting failures, root causes, and the prompt changes that resolve them. Validation loop code with retry logic. A recommendation section addressing the cost and throughput trade-offs between Claude Sonnet and Claude Haiku models. In 4 hours, you've moved from the fundamental concepts of agentic architecture to a working implementation of a multi-tool customer support agent with MCP integration, a production-grade Claude, B configuration for a fintech code base, and a structured extraction pipeline with schema validation and retry logic. The offline milestones before month 2 are designed to reinforce today's work with real-world application. Register for the Claude Certified Architect exam before exam slots fill. Don't let this slip. Extend the prototype by adding a lookup transaction history tool that returns the last 10 transactions and integrates it into the refund flow. Refactor the single agent support system into an orchestrator with 2 subagents, an account specialist and a payment specialist, to experience parallel fan-out in practice. Deploy your Claude mid to a real team repository and document one interaction where plan mode prevented an unintended change. Run your NIC and bank statement extractor on 50 anonymized real format documents and measure your actual schema validity rate, not the rate from the test cases you designed. The 3 resources to prioritize before month 2 are Anthropic's Building Effective Agents research paper, the Claude Agent SDK GitHub repository with its multi-agent cookbook examples, and the MCP specifications core concepts and tool schema sections. Month 2 builds directly on today's foundation. We'll go deeper on multi-agent reliability patterns, production observability on Azure, and deployment architecture for high availability MCP server infrastructure. See you in 4 weeks.